So in this video, we're going to talk about the idea of hydration of a double bond. So if we take any alkene and we add acid, which is H plus, in water, we actually get the alcohol. Excuse me. But we get the alcohol. So this would be the product. Again, there's the H and then there's the H2O. So essentially, we're adding water across a double bond. So this is what we call hydration of a double bond. Now, remember that the Markovnikov product still applies here, right? So, meaning that the nucleophile is going to be on the more substituted carbon. So if I take an example, predict the products of this reaction. If I take this molecule and add it in acid and water, essentially the product that I get is the alcohol version. This would be the product. So how do we predict, what is the reaction mechanism behind the hydration of a double bond? Let's look at it. Again, if we take the molecule, if we take the original alkene, the first thing that's going to occur is that the alkene is going to act as a nucleophile, no surprisingly, and attack the H plus ion, or the acid in solution. This is a result, again, and let me label this with some arbitrary number, but let's say this is carbon 1 and this is carbon 0. Well, on carbon 1, we have one hydrogen, we just didn't write it in. Carbon 0 contains no hydrogens, so therefore carbon 0 is more substituted, so therefore we should expect, according to Markovnikov's rule, that the nucleophile will be on carbon 0, again, the more substituted carbon. So therefore, double bond comes in, attacks the H plus ion, and we're going to form a carbocation. Right, so carbocation is going to be on the more substituted carbon. We initially had one hydrogen before. There's a second hydrogen that we just added. In the second step of the reaction, the water molecule now, the oxygen portion comes in and act as a nucleophile. So it will come in and attack the carbocation. As a result, I get a carbon that's bonded to an oxygen that has two hydrogen molecules. Now remember that this oxygen now has one pair of lone pairs, so therefore this must be a positive charge. And the third step of the reaction, another water molecule now comes in and acts as a base. So it comes in, takes off one of the hydrogens, and put it in the form of lone pair in the oxygen. So essentially, our final product is this molecule. So again, this is the idea of hydration of a double bond. Right? Predict the products of this reaction. If I take this alkene and I add H plus in water, what is a product? And a more that should be a CH3. I'm getting ahead of myself here, right? So that would be the product. Now, if you look on either side of the carbon of the alkene, we both have one hydrogen, and so it doesn't matter. I could also written the product as, let me scroll up a little bit more. So in this case, it doesn't matter because the carbon substitution pattern is actually equal. So I could have also wrote this as that way, essentially. Right? But again, whenever a carbon is more substituted, you have to remember to apply Markovnikov's rule.